20 megahertz of total spectrum is allocated for a duplex wireless cellular system each simplex channel has 25 kilohertz RF bandwidth. Then find first is number of duplex channels, and B total number of channels per cell site. If n is equal to 4, cell reuse is used. So we have to find the number of duplex channel and total number of channels per cell site. So we have formula for both these two. So first we find out the number of duplex channel. So here we write to find number of duplex channels it is equal to 20 into 10 raised to 6 divided by 25 into 10 raised to 3 into 2. So it is 400. And second, if n is equal to 4, then find the number of channels per cell. So it is 400 divided by 4, that is 100. Now next problem, show that the frequency reuse factor for cellular system is given by K by S, where K is average number channels per cell and S is total number of channels available to cellular service provider. So, if each cell is allocated a group of K channels and if S channels are divided among N cells, we write down here. So, if each cell is allocated a group of K channel, if each cell is allocated a group of K channels, so K less than S, and if S channels are divided among N cells into unique and disjoint channel group with each having same number of channels, then total number of radio channels available is S is equal to Kn, where N is cluster size. Frequency reuse factor of system is frequency reuse factor of system is 1 by N. Therefore, 1 by N is equal to K by S. Thus prove that the frequency reuse factor for cellular system is given by K by S. Now next problem. For a given path loss component, for and frequency reuse factor of n is equal to 7, then calculate S by I ratio in cellular system. So given that n is equal to 4 and capital N is 7, d by r it is square root of 3n, so it is 3 into 7, that is 4.582. Next, s by I it is square root of 3n divided by so we substitute values here 1 by 6 into 2.582 raised to 4. So it is 73.46. So S by I is 10 to the log of 73.46 and its value is dB. So this problem was asked in same exam for 4 marks. So next problem. Suppose the mobile station is moving suppose that a mobile station is moving along a straight smooth surface between base station BS1 and BS2. The distance between BS1 and BS2 is 2000 meter. So assume that the received power in dB and at base station is given by PR is equal to P0 minus 10 into N into log of D by D0, where D is what? It is distance between mobile station and base station in meter, and P0 is the power at distance D0. P0 is power at distance D0 from mobile. So assume P0 is equal to 0 dBm and D0 is 1 meter, and consider N denote path loss exponent, which is 2.9. Given that minimum usable level of signal is minus 88 dBm, and mobile station is currently connected to BS1. So we have to determine the handoff margin. We write here determine handoff margin if handoff time is 4.5 seconds and mobile speed is 100 kilometer per hour. So what is given? Mobile speed is given. Mobile speed. What is mobile speed? It is 100 kilometer per hour. What is P0? P0 is 0 dBm. D0 is 1 meter. And N is what? It is 2.9 PR. It is minus 88 dBm. And handoff time is, it is 4.5 seconds. So PR minimum, it is P0 minus 10n log of D minimum by D0. So we substitute value here, 0 minus 10 into it is minus 88. So it is equal to anti-log. This term becomes on term. So it becomes anti-log of 88 by 29. This value is 1082.63 meter. This is the distance. Now PRHO is received signal power at handoff threshold. So PRHO, it is P0 minus 10n log of DRHO divided by 0. It is equal to 0 minus 10 into 2.9 divided by 1. So it becomes 29 log of DRHO. So we write here DRHO equal to anti-log log of minus PR divided by 29. So during handoff calls are not lost due to weak signal condition. We write here during handoff calls are not lost due to weak signal condition if distance traveled during handoff divided by mobile speed. So it is greater than or equal to handoff time. So D minimum minus DRHO divided by 100 kilometer per hour greater than or equal to 4.5 seconds. So it is 1082.63 minus PR by 29 . So we can solve this equation. So 1082.63 minus anti-log of PR 124.96. This term goes this side. Okay, now therefore minus of anti-log of minus PRHO by 29, it is greater than equal to minus 957.6. now we taking log of both sides. So minus PRHO by 29 therefore delta is equal to end of margin, that is equal to PRHO minus PR minimum. So it is minus 86.455 minus of minus 88. So delta value is 1.544 dpm. So in this way we can solve this problem.